Hello? Okay, cool.
Sounds good. Okay.
Yeah, all right. We can actually start here. Thank you for coming to this session. My name is Ankit Astana. I'm a PM on the .NET team, and with me I have Cesar. He's also from the .NET team. And what we're going to be talking about today is modernizing existing .NET web apps with Azure Cloud and Windows Containers. So let's get started. So here's kind of like a rough outline in terms of what we're going to cover over the next hour or so. We're going to start with the .NET Application Architecture Portal. And this is essentially a place that we've created for folks such as yourself, where we provide prescriptive guidance and best practices from Microsoft. We're then going to get into the modernization maturity model, which is really a way to think about how to approach modernization for web apps. When you're faced with that problem, what are the things that you can look at, what are the stages that we recommend, and so on. And a lot of this content here in this maturity model is going to be very, very Azure specific, but a lot of this content will still apply for you as well in a scenario where you have VMs on premise and so on. So take that with a grain of salt. And at the end, we'll leave enough time for you folks to ask us questions. But if there is a burning question that you guys have or people have, by all means let us know and we'll try our best to get that addressed.
And in between, we'll do a bunch of demos about Windows Containers and Azure.
So here's kind of like some background about the .NET Application Architecture Portal. How many people have actually seen the .NET Architecture Portal, this picture, before? Well, there's actually a number of hands here. I'm actually quite surprised there. That's great. So we've heard a lot of feedback from folks such as yourself that the .NET team or the Microsoft team in general hasn't given a lot of best practice or prescriptive guidance across building microservices, web apps, mobile apps, UWP apps, and so on over a long period of time. So this is kind of like taking your feedback into account. This is what we've created. And all of these books, essentially ebooks, also come accompanied with sample applications or reference applications that you can use to get started. So if you want to see an example of a code, or you just want to get your hands dirty, or you want to base your application on this architecture, you can actually use these as samples. And as you can see, we've actually had a lot of success here and a lot of love that we've seen from the .NET community in general, where you can see that we have 250,000 downloads already in the last 3-4 months. And the repos that we've created with the samples, there's a lot of GitHub stars there already, so almost 3.5K stars there. Now, having said that, Cesar, don't we have something new to introduce you today as well?
Yeah, so we are very excited. So today we are announcing something new about the .NET architecture side. So we've been creating and working on this guidance, precisely the topic, the subject of this session, which is about modernizing or migrating existing .NET applications with Windows Containers and to Azure, right? So we also created a couple of reference applications showing you how to migrate to Azure in Windows Containers. And not just that, also here you can see the repo, the page. So this is the new area for modernizing existing .NET applications, the PDF, the ebook, and also the reference applications. And a new area that we also added is about a reference application for desktop applications with the Universal Windows Platform. So this is also new since yesterday, and a reference application for that. And here you have the repos. So eShop on Containers is the one that I'm driving for microservices, and this is the talk that I just delivered a few, 1 hour ago. And then eShop Modernizing is about migrating existing .NET applications with Windows Containers and Azure. So this is the content. And then the last one is UWP, which is a different subject, right? So let's continue.
Cool. So you should actually go ahead and download this ebook if you want to follow along. This talk is really just a sum up or a wrap up of what's there in the book already. And the examples and the demos we're going to be showing you are essentially the reference applications that are mentioned there. And we're going to walk them through the journey of containerizing them with Docker containers, pushing them into the cloud with CI/CD workflows, and production orchestration with Service Fabric and Kubernetes. So that's really what this talk is really about. And if you want to learn more, you can obviously learn more from the book, but this is something that we recommend. So a fair question to perhaps ask, some of you folks in the crowd might think that, hey, my app already works great. It works, it runs, it does what it's supposed to do. Why should I actually go about modernizing it? And this is, to be honest, a fair question to ask. And me and Cesar have kind of like been working with different firms and companies over the last few months. And it kind of like, the need for modernization or the benefits of modernization eventually kind of like boil down to kind of like these 4 things, They're not in any particular order, but essentially a lot of firms that we work with, essentially their need to modernize is about, we want standardized software being deployed across different deployments. So the need for modernization for them is about simplifying the ID workflow. We work in an environment these days where we're trying to ship new features, every day or every week, new products that we're shipping and all that kind of stuff. So the need for agility is usually a strong driver for modernization as well. If you set up an automated DevOps story with containers, with a CI/CD workflow, you can essentially, change your inner loop from pushing a change from a development environment to production from a matter of hours or days, in some cases, to minutes. And that's really, the agility you folks might need for your applications. Another thing that comes up allows us time to market. So once you've kind of like published your apps to the cloud, things like scalability, things like high availability, you'll get this pretty much for free. And if you set this up right, you can also get advanced analytics about how your end customers are using your product, what kind of experiences are they using more, and you can then take that data into account and build for the future. And for the folks who are the CIOs and the CTOs and execs in the room perhaps, modernization is also actually cheaper in the pocket. You no longer have to pay for infrastructure cost. You also, in most cases, don't have to pay for the ongoing maintenance costs that you pay for upgrades or just maintaining your software or deployments and so on. So those are kind of like some of the reasons, in the sense, we've seen a lot of folks mention about when they're going through this journey of modernization for their existing applications. I hope some of these resonate with you as well, but that's kind of like some of the things that we've learned. So moving forward, how do you actually get started? This is a big problem. You might have a huge application, or you might have many folks involved in building this application over a period of time. So how do you actually get started? So what we've done here for this journey essentially is that we're actually talking about here is a cloud maturity model. And what this maturity model is essentially a way for you to think about how to approach the problem of modernization in general for your web applications. And the maturity model here that you're seeing here is kind of like broken down into 2 stages or 2 approaches. There's the lift and shift approach, which for the most part does not require you to make any code changes. It does not require you to re-architect your app. And we kind of like further break down the lift and shift stuff to cloud infrastructure ready and cloud DevOps ready. What these exactly are is what we're going to get into next. And the other approach that we're going to talk about very, very briefly, because these are really, really large topics by themselves, is the cloud optimized approach or architect for the cloud approach. This is basically, if you have a lot of time on your hands, if you really want to get the entire cloud benefit, maximum agility, you can actually go and architect, re-architect, and in some cases recode some of major portions of your application to take into account or to take benefit of architecture patterns like microservices, serverless computing, and all that kind of stuff to build cloud optimized applications. So for this talk, we're going to primarily focus this on the lift and shift scenarios because we're talking about existing applications, while we'll very briefly also get into cloud optimized at the end. So this is kind of like just a way to think about it. So let's take a look at the cloud infrastructure ready part, which is the first lift and shift approach that we're going to look into. So as the kind of like the name suggests there, cloud infrastructure ready, it's really about, the way we think about it is about simply rehosting your on-premise application to IaaS on Azure. IaaS on Azure here means VMs on Azure essentially. So you have your existing app, and you want to essentially rehost this in an IaaS cloud. And to be honest, there's a lot of good things about this approach. The first good thing is that there is really no re-architecture involved. There is no new code involved. So the migration from that perspective is going to be much simpler. In terms of the effort involved in this migration, probably the least effort migration that you'll probably go through, in my opinion, in our opinion. And the third thing that you're going to see here, the advantage of this approach is that it's also supported on the least common denominator on Azure, which is VMs, which is also a very cloud agnostic pattern, whether you're using Azure or some other cloud for that matter. So these are kind of like some of the pros that you'll see with the cloud infrastructure ready kind of like scenario that we define. which you can take a look into if that scenario is right for you. We're not going to cover this in a lot of detail either, but me and Cesar have actually gone through a lot of tools and resources that we found on the web, and we've kind of like collected them together for this scenario. The first thing we want to kind of like talk about and you should take a look into is Azure Migrate. This was talked about at the keynote a couple of days back as well at length. There's a public preview. You can actually sign up for this. Another resource here is Azure Site Recovery. I'm not sure if people are aware of Azure Site Recovery here, but if you're trying to move your on-premise website to the cloud, you can actually use Azure Site Recovery. So this is for your web app. For your data migration story, you actually have, we actually have Azure SQL Managed Instant, which is kind of like a PaaS offering on Azure. And we recently kind of like announced and built the database migration service, which we also talked about again on Monday. So there's another link and resource there that you can take a look into for migrating your data. But these are like the 3 places where I would essentially start if this scenario, cloud infrastructure ready, actually appeals to you. And then there's a bunch of resources in there as well for migrating VMs. In some cases, if you want to set up a hybrid environment, there's a bunch of resources there that you can take a look into as well. So that kind of like brings us back to this picture here. But so what are some of the, so there's obviously some benefits here. You no longer are paying infrastructure cost anymore because you're managing your infrastructure in the cloud. But there's also a lot of cons here with this approach. The problem with this approach is that you still have to worry about your ongoing maintenance, which means that you still have to worry about manual patching. If you're trying to set up high availability, that's kind of like something you have to do on your own. If you're setting up automatic app scaling, that's something else you have to do on your own. So there must be a better way. Cesar, what do you think? Is there a better way?
For sure.
So what we're going to do is we're going to actually go into the second way of lift and shift, which is cloud DevOps ready. And this is something we're going to spend a lot of time in this talk, and Cesar is going to talk about this.
Thanks a lot, Ankit. Yeah, so this is about cloud DevOps ready. Something I want to highlight is that when we are saying DevOps ready, we are not meaning just DevOps tooling, tools like VSTS, things like that. That will come later. But DevOps ready means really having the infrastructure ready for DevOps. So that's why the most important thing here for DevOps is probably containers and Windows containers for existing applications. And that is going to help a lot the DevOps experience. Because it's not just about tooling. It's also about having your application in a package with all the dependencies, and you provide that to production, and that is going to work. Okay? So it's about containers and Docker, and that's going to simplify a lot all the issues when deploying in production. Okay? So this is the main point I want to highlight. Probably many of you might know Docker. Some of you might not. It's a buzzword, and everybody's talking about that. But to me, something is, okay, why should I use Docker? And it's all the points that I said a few minutes ago. But also, kind of a bottom line to simplify this, I would say is, have you ever been in this situation yourself or when talking to a developer when you say, hey, we have this issue in production, but it's working in my machine, in my development machine works. Why not in production? That's super common, right? So that is precisely what Docker solves. Because when you create an image and you deploy a container with that image, that is coming with all the dependencies. Because usually when you deploy something, a regular application into production, and then it is failing, it's because some dependency that you have in the development machine, you don't have that in production. And then the containers are providing all the dependencies that you need, even the framework, this other sub-framework, the other, whatever. It's going to be in that container coming along with your Docker container. So that's kind of the key and why. And then Docker is also running on Linux or Windows. And it's going to be better and better on both at the same time. It's multi-architecture. It's going to be even better. So that's the main point. Then you could compare Docker containers to virtual machines, although I don't really love this comparison, but many people do, so I want to highlight something important. So even when a container is kind of a virtualization, you have your own IP for each container, and you are protecting and isolating that. That is kind of similar to a VM, but it is very different in the sense that in a regular Docker host, the operating system is being shared across all the containers. That's one point. And then the other point is each container is going to be composed by your application, as you see there, like application or service 1, application service 2, plus all the dependencies, all the binaries, all the libraries that you need for that application to run, okay? So from a development point of view, I would think about a container more than comparing that to a VM. Think about a container as a process. It's like a process plus all the dependencies, all in a box. It's like if you put in a zip file, let's say, all the dependencies with your process, but when you start a container, it's more like a process with all the dependencies, okay? Because a container has a single entry point, which is a single process usually, okay? So yeah, it's like that zip file, that image with your application, but also it has network isolation, and you can also set constraints about memory or consumption in the container, okay? Again, just to mention that you can run containers on Windows and Linux. It's not okay. And then about .NET. So in .NET, we have two kind of images. We have a full .NET Framework image for Docker, and then it's going to be just for Windows Server Core, because full .NET, the traditional .NET runs only on Windows. And then for .NET Core, we have as well Docker images, and in that case, it can run either on Linux or on Windows Nano Server. So the first type of images is what we're going to be talking about in this session, because we are lifting and shifting or modernizing existing .NET applications. The second image, using .NET Core and on Linux or Windows Nano, I would use it for new applications, microservices, where you want small microservices, a small memory footprint, and so on. I recommend .NET Core. But in this case, you just have something, either existing or legacy, and you want to wrap it around with Windows containers without touching the application, the code. And then is Windows containers with full .NET Framework, okay? So let's do a demo about this. This is the, okay. So we created two sample applications with full .NET Framework. One is WebForms, and the other one is traditional MVC. So full framework is not core. And we are going to containerize with Windows containers those applications. First of all, this is a development machine. When you install Docker for Windows, you have these settings. You can see the properties for Docker. Most of all, you could also, from here, you can select if you want to switch to Linux containers and then run that into a Linux VM that gets installed. Or in this case, we're going to be using Windows containers. So it's going to be running natively in Windows 10. So if I do here now Docker PS, I don't have any container running yet. But you see if I do Docker info, then it's saying that I have Windows 10 Enterprise and so on, okay? So what we're going to do is we have these applications. In this case, I'm going to do the demo with the MVC application. You see here, it's a regular .NET, ASP.NET MVC, nothing new. It's not .NET Core. Could be the WebForms as well. And by the way, we're going to Dockerize this with Visual Studio. But I want to highlight that what Visual Studio does now is super simple. It's just adding 3 files, or 4 files. You could do the same manually, copying those files to a folder where you have your application and just the binaries of your application, not the source code, and you would do the same, okay? So, but in this case, I'm just using Visual Studio because it's simpler. So you just do right-click, add Docker support, and yes, and then you get 3 files added. One is the Docker file here at the project level, and the other files are the Docker compose files up above, okay? So before getting into those details, I want to highlight that when this application was running, in IIS, no Docker, we are using, settings in web.config. For instance, we have, the connection string, or we have these settings that if I want to use mock data, so instead of going to SQL, I generate that data in memory and show it. So for tests, it's better. you'll see that when using Windows containers, instead of using the web.config, we will use the Docker Compose files and environment variables. That will change. So it will be overridden these files, this information. Okay. So then the Docker file. Docker file is like one Docker file per application, per process. And basically, it's saying, OK, I'm going to use this Docker image, base image. And this is the ASP.NET image, which is based on, it's kind of in layers, based on full .NET framework. And it's going to be using Windows Server Core. So that version is larger in Windows. It has IIS and everything I might need for full .NET framework. Another important thing is here, the version. So if you're using images, one question would be, OK, so how do I update my applications so it is patched, it is coming with the latest version, and so on. So it's just by doing this in this file, instead of this version, I could say 4.7 or even just latest. So whenever I create the Docker image, it will grab the latest version, which is updated for security things or whatever. Okay. So just gonna go back, and that's about the Docker file is also saying where it's going to start the process in the image. Okay, and the other files are the Docker Compose files. So in Docker Compose is a way to provide how you want to deploy the application. So those files are not part of the application, are not part of the container, but just a way to configure your application and when you deploy it into Docker. Okay, so you do Docker Compose app, it will take these values and deploy that. You could also do Docker run and then provide a bunch of arguments in Docker runs, but this is a lot easier because you write all the arguments, all the information in Docker Compose, and then you just do Docker Compose app, and it gets deployed, right? So here you can see in this Docker Compose file that is using, is going to create this image, eShop, legacy, MVC, and then the Docker file that it's going to be using. That's kind of the static information for Docker in the Docker Compose file. Then you have the second Docker Compose, which is this one. You see Docker Compose override. And this is where you put the settings specific for the environment. So in this case, I'm saying it's going to run in port 80. But maybe if I deploy this into production, maybe it's going to be a different port. So that's information related to the environment. You will do it on deployment time, OK? And yeah, let's just run it. I should have done it while talking, because it's going to take a minute or so. Just want to show you that the great thing about using Visual Studio with Docker is that you can debug the containers from Visual Studio. I just put here a breakpoint within the MVC controller, and now it's starting all the container here. You can see if I go do Docker PS, the container is now up and running. And it's going to take just a few seconds because it's creating that data, mock data, populating that sample data. So the application is going to have everything. And then now it's attaching to process. And in a couple of seconds, it's going to show you the breakpoint. Also, the first time is creating the Docker image with your bits. So here you see the breakpoint. So you can debug, and it's going inside the container. Again, I'm just going to continue. It's going to come again and continue, and you'll see the application. OK. And here's the application. This is the MVC app. It is like a manager, so you can CRUD application, you can delete, update, and create new products for eShop. It's using the same eShop catalog database that we are using in the microservices application. So you can edit, and in this case, because we just deployed that container, is using sample data in memory. So I'm going to stop this and just show you the other kind of modernized version, which is pretty similar. The only thing that we added here is in the Docker Compose, we also added this information which is saying, hey, when I do Docker Compose, I deploy the application, I also want to start a SQL container. And just by doing that, we will have a SQL server running in a container. And then in the Docker Compose, here we can specify different ports, like I said, or the connection string as an environment variable. I'm saying, in this case, it's using mock data, but it just say, sorry, it's not using it, so it is false. It will use SQL. And then here's the information for SQL to start the first time, providing the SA password and what port is going to be running. Okay? So if I run this again, it will be the same thing, but now accessing the SQL database in a container.
And sorry, Cesar,
yeah.
And in the last one, like we were just mocking data running in one container. Is that what we were doing? Like in the other version, the non-modernized version that you just showed?
Yeah, in the not modernized, because it was just that container, right. You didn't see anything about SQL. There was data just in memory.
But in this one, we have two containers, one running SQL now and one running the
In this one, we have both SQL, and I will show that now later when deploying to VM in Azure. Okay, but yeah, that's pretty much. And let's move to the deck, and we'll continue. Yeah, so related to what you saw is, okay, you don't really need Visual Studio to just get the legacy application. You just need the bits and the information, and then you put the Docker file and Docker Compose. You create the image, the Docker image with Docker build, and that will get all those bits, binary bits. Then based on the Docker file, we'll create the image, like that package, and then you will be able to deploy it. If it is a very simple application, that's enough. If it is like an application you have in a server and there are many, many configurations and dependencies in that IIS box and so on, Docker created this tool, which is called image to Docker. So it goes to an IIS server where you can have that application with a lot of different configurations and maybe, I don't know, like settings in IIS, host header, using this other application, dependency in this MSI that has to be installed in the box, or it's a WCF and you need to activate WCF in IIS and so on. So image to Docker will explore that and will generate the Docker file with all that configuration for Windows for you. So you don't have to research how to do that. Okay, so this is pretty convenient. And you just need the binaries and the IIS box. You don't really need the code. Okay, so that's why I was showing that in Visual Studio, but you could also do it with just the binaries. So next scenario is, okay, we have what I just showed you. We have the PC, the development environment. We have the ASP.NET MVC or the WebForms application in a container. We have the SQL container, and we have Docker in that PC environment. What I want to do now is I want to deploy that into a VM. So the way you do it is once I have the Docker image locally, you see the local Docker image repository, you need to push that into the Docker registry. Okay, so you push that into the Docker registry. A Docker registry is like a large repository where you can upload your images. Docker has a public one, which is called Docker Hub, and Microsoft has another one in Azure. It's called Azure Container Registry. So if it is something private, it's better if you use the one in Azure because it's also with less latency with your application when grabbing the images. If it is something public, everybody's putting public images in Docker Hub when it's like a base image, okay? And once you have the images in Docker Hub, then I can just deploy that into the VM. I can go to the VM and I do Docker pull just to grab the image, or just a Docker Compose app, and then it will say, hey, I don't have the image, so I will grab it from from the registry and deploy it. Okay, so this is the demo I want to do. Well, I'm going to do the whole thing also about CI/CD. So that's manually. Once you have, you know how it works, then you also want to do it properly, which is you want to have CI, continuous integration, and continuous deployment in VSTS or any other system, Jenkins or whatever. So basically, you have the development environment, and then you're not going to create the Docker images from the PC, from the dev environment. You are going to do it from the CI and CD pipeline. So from the development environment, I will just push to Git, and then from Git is where you have the code, and sometimes it's not working. Yeah, and then in Visual Studio Team Services or Jenkins is where you grab that code from GitHub or Git or any repo with the source code, and you build your application. And right after building that, which is kind of what you know, the difference here in this life cycle with Docker is that from that CI pipeline, you push that into the Docker registry. Like I could do it manually, but this is done from the CI pipeline. And once you have that image in the Docker registry, either Azure Container Registry or Docker Hub, then you have your continuous deployment or deployment pipelines, and you will deploy that into either a VM, like I'm going to do now, like a VM for testing, or later on, I will show you how you can do also that with orchestrators for containers. So let's do a demo about that. OK, so first thing is I have VM in Azure. This is the VM. You see, well, you can connect to it, et cetera. I just connected to it from here. You see, this is the IP of the VM. I just controlling the VM. And I have this page open just to show you that this is what we're going to be using. So this is Docker Hub. OK, so you see here Docker Hub. And then this is the image, eShop Modernize MVC or eShop Modernize WebForms. There are a bunch of other images about the eShop on containers and microservices, but in this case, we're using just these two, OK? So then, OK, this is the VM. You can see that right now, I don't have any container running in the VM with Docker PS, nothing there. The way I would deploy this manually to the VM is with this line that you see below, Docker compose, and then Docker compose no build, and Docker compose override. Basically, those files are the only files that I just need to deploy the VM. Because the image is in the registry, I just need to copy the Docker compose files into a folder, like I did in there. I don't have any binary, I don't have any code, just those two files. That you can see here. And the difference is that the Docker Compose is renamed to no build. Why? Because I'm not building the Docker image. I just want to pull the image from the registry. So I'm just saying, hey, this is the image, eShop Modernize MVC. You saw that in Docker Hub. It depends on the SQL image. I just want to deploy that. So, and then the override is the settings for this specific environment, like the ports I want to use, the connection string, and that's it. So I just need those two files, nothing else in the VM. And when you do this command, Docker compose, and saying this, Docker compose no build on the other one, and instead of down, it will be up. Then it will grab, pull the images, and run it. I'm not going to do it because I'm going to do it from VSTS. It takes a couple of minutes, but it would be just running that command. Something else that you can do is, OK, I want to do the same, but from the outside. I don't want to control the VM like I'm doing now. I can do it from the development environment. So you can see here, this is the development environment. If I do Docker info, you can see this is my Windows 10 machine, right? And this is my PC, SysRDL, OK? So what I'm going to do is, instead of using my local PC, is to connect using Docker CLI to the VM. So for that, you need just to have certificates locally in my PC, and then using those certificates to connect to the VM. Everything I'm saying here, by the way, is in the GitHub repo with these sample applications. There are a very step-by-step walkthroughs saying everything, the certificates, all the steps. Okay, so this is just a summary. But then once you have the certificates, what you can do is something like this command. So it's Docker, and it's Docker info, but then providing the position of the certificate. So when I do this, it is connecting to the VM, because you can see here, now the information about Docker host is not my local machine. Now it is Windows Server in Azure, and this is the name of the VM in Azure. So in the same way that I'm grabbing this information from the VM, I could also do this other command, which is, I'm not going to run it because I will do it from VSTS. But you see, I would be doing Docker compose, providing the certificates I need, and then the two files, Docker compose no build and Docker compose override, up. And just by doing this in my development machine, I will spin up the containers in the VM in Azure. Okay? So same thing would be doing this in VSTS. So let's go here. So in VSTS, you see in there that's the build pipeline. So in VSTS, we are compiling, building the eShop Modernize project, and once I have the bits, we build the image. Basically, is Docker compose build, and then I will have those images in the build machine, and then we push that image into the registry. The thing that I did manually, I would have done manually with Docker push. This is done from the build. And once this build is done, this build pipeline, that means that the image is going to be here in Docker Hub or Azure Container Registry. Okay? And once I have the images here available for anyone to consume, then you go to the releases or the continuous deployment release. So this is now to deploy. The other one was to build the image. Now this is to deploy. So we have this pipeline, deploy pipeline. Basically, it is accessing with this artifact, basically it's accessing GitHub because I need those two famous files, the Docker Compose and the Docker Compose override. I need those files so VSTS knows how to deploy, right? So I grab those two files, just two files from GitHub, and then I run the deployment tasks, which is going to be similar to what I showed you in the CLI. So I commented to stop the containers, remove the image, get the latest image, and get the latest image for SQL, because that would be taking more time. And the only thing I'm going to be doing is to deploy into the VM. But just want to highlight that it's going to be doing exactly the same that I was doing in the CLI. So you see is doing Docker Compose app and then using the Docker no build and the Docker override, right? And that's it. You can also specify environment variables from here, so it's more secure. And then the command is Docker Compose app, right here. So let's run it. Create release. Select version, GitHub, Q. And again, what VST is doing here, let's go to the releases, but it is the same that I would do here manually in the VM with Docker Compose app with these two files, okay? So here's the release. It's running, deploying to the VM. It is in progress, grabbing those two files from GitHub, in progress. So while it is deploying, let's move now to the VM. Okay, so this is the VM. If I do now Docker, here, Docker PS, yep, there's the SQL container here running already, and we should have the other one in a minute. Let's see how this is going from here. We can see the logs in VSTS. So you see deploying now. Now it's finished, so everything is deployed. So if I go to the VM, do Docker PS, well, yes, it's in there here. So this is the MVC application, and this is the SQL container. Okay, so now we have both things deployed in the VM. I can go from the outside and just test the app. So just so you see this IP of the VM, 1391 and so on. This is the same IP I'm putting here in the browser. Or I also created a DNS name, same port, so it's going to be the same. So it's going to take like 30 seconds because it is populating that data now for real in SQL Server. And just so you see it is for real in SQL Server, what we're going to do is we're going to connect to that SQL container in the VM from SQL Manager. So let's connect from here. This is the same IP, the port we're using, password. And boom, it's connected. So we can see the database here. And remember, that VM didn't have anything about SQL. Now it has the SQL container. Something I want to highlight also is SQL container, a SQL Server in a container is great for development and test environment. It's not for production. So for a production, I would move the database to SQL Azure database or any cluster, or but this is great for testing, not for production, because you won't have high availability in a container. Okay, but you see I'm connected here. This is the database. I'm going to edit the table, and let's go to the application. Yeah, so the application is running in the VM now with real data in SQL. And just so I prove that this is data for real in SQL, I'm editing this table and changing this named hoodie SQL. So now it's updated in the database. Let's move to here, refresh. And there you go. So it's grabbing now the information from SQL, and here again. Okay? So I think that's all about the VM. Let's move to the next topic. Okay, so now let's talk about production. And this is related to what I just mentioned. So the first thing would be the data. So for testing, QA, I can use a SQL container. But for production, I would move that to Azure SQL Database or Azure SQL Database Managed Instance if it is like a complex application. I'm sorry, it's a complex database with many more things that a regular SQL database, or even a SQL Server cluster on premises, right? So with that, you have high availability. And if it is in Azure, you also have a PaaS service. But what about the containers? Because right now, I just had a single instance per image, right? So if you want to scale out, you cannot do that with a single VM. You could do it manually and create a few VMs like that and then load balancing, but that would be kind of infrastructure work. And so for this, if I want to scale out containers, the best thing to go is an orchestrator for containers. So that's the answer for that. If you want to scale out, if it is just for testing, VM is OK. Or if it is a very, very small application. But if you want to scale out, you should go to an orchestrator. So orchestrators, there are a few. In Azure, we have all of those. We have Azure Service Fabric, which is very mature, using Windows, less mature on Linux. And then we have Azure Container Service, which has 3 open source orchestrators: Kubernetes, Mesosphere, DCOS, and Docker Swarm. So from all of those, we personally would recommend either Kubernetes or Service Fabric. Kubernetes is more mature on Linux, preview in Windows, but for all the demos that I'm doing for here as well are in Service Fabric and also Kubernetes on Windows containers. And pretty soon it's going to be GA, Kubernetes on Windows containers as well. So I would recommend that you evaluate both. You can play with them, and depending on what fits better for you, you can go. Docker Swarm is not so not so strong for production environments. And then DCOS is great for production environments, but it's a lot more complex. So usually it's more for data-oriented scenarios within that cluster. So that's why we recommend Service Fabric or Kubernetes. So let's see another scenario. So we have that development environment, Docker, same thing that we had previously. But now we also we're going to deploy into Kubernetes. So we need to have the Kubernetes CLI and kubectl installed on the local machine in the development environment. About the images, it would be exactly the same. So we will have the container images that we need to deploy in the Docker registry, Docker Hub or Azure Container Registry. Would do a Docker push if I do it from locally from my development machine, or I would do a Docker push from the build pipeline in VSTS. The point is that you need to have those images in the Docker registry. Once you have the images there available to consume, then in this case, instead of having a VM, we have a cluster of Kubernetes. So in ACS, in Azure Container Service. So a cluster is nothing more than a group of VMs. In the case of Kubernetes, you have the master node is always Linux, and then the nodes where you deploy your containers could be Linux or Windows. In this case, because we are deploying Windows containers, it's got to be Windows, right? So then after that, if you want to deploy manually from your development machine to the cluster, what you do is the command you see in there, kubectl create and provide the metadata that Kubernetes needs to deploy that application. That metadata is YAML. It's pretty similar to the Docker Compose metadata, but it's in a different YAML format. I will show that to you in a moment. Also, Kubernetes and also Service Fabric, they are also in preview, so you could use Docker Compose metadata instead of their own metadata, okay? But the important point here is that you just need that definition. It's very simple, just some metadata definition. The images are in the registry are going to be the same for the VM or for Kubernetes or for Service Fabric. That's kind of the beauty of Docker containers, because it's kind of, Docker containers are really becoming the unit of deployment. That's kind of something remarkable. So then you deploy those containers. You see that I would have SQL container just in one machine, but then my stateless container could be in multiple machines, as many as I want. If I have 50 VMs, I could have 50 containers or more, but not the SQL, because the SQL container has to be just one because it's a single database, right? So for testing would be good. Then if you are really going to production, I would extract that SQL container and put it in Azure SQL database or managed instance. And again, similar scenario than before, build CI, push into Docker registry, this is the same. But now the difference is that we are deploying to a ACS Kubernetes cluster. And I will show you that now also in VSTS. So so let's see this application in Kubernetes, also in Service Fabric. I'm going to show you very quick. So in this case, now you see here in Azure, I have a cluster of Kubernetes in container service. And then we will get into this, which is the Kubernetes dashboard, where you can see all the deployments and so on. And you can see this is the IP of the application, 52.160. So I have the same application running in Kubernetes in this page. Again, I also have the same deployment into Service Fabric. So this is a Service Fabric cluster. And then this is the kind of dashboard, or it's called Service Fabric Explorer, where you can also see that I have the SQL container deployed, and the application deployed. Let's zoom a little bit. The MVC application, the SQL container, and in this case, I also have deployed the WebForms, ASP.NET WebForms application, okay? And here you can see the same application in the DNS name for Service Fabric, which is the same than the Explorer, okay? So you can deploy the same images, same containers to the multiple clusters. Let's scale out, for instance, in Kubernetes. So in Kubernetes, I have the services, which is kind of what I'm publishing to the outside world. And then I have the deployments. The deployments is what I'm deploying, kind of the type. And then you can have many instances of those deployments. So in this case, we have the SQL container, the WebForms application, and the MVC application. I left it on 3. Let's scale out now from 3 containers to 5 or whatever, right? Could be any number. Is that simple? You can also do this from the CLI command line. Now it's deploying more instances. You can also see pods, which are the instances. So it's creating 2 more pods or 2 more containers for this application. So I have 1, 2, 3, 4, and 5 for the MVC, 1 for the WebForms, and 1 for SQL. And in a couple of seconds, it will be done. But I don't know why it's having an issue grabbing the image. But is that simple? The other way you can do it is from the command line. So first of all, the way, because I'm accessing the dashboard, is because I'm using this kubectl proxy. And then based on the certificates I have in this machine, that's why when I go to the dashboard here, it's using localhost 8001 because of the proxy. But this is running in Azure, right? And you can also use the kubectl CLI, and I can say, let's say, get services, and this will access the Kubernetes cluster and show me the IPs and the ports I'm using. You see the MVC application, this internal, external IP, and then if I do, instead of services, if I do deployments, then you'll see the multiple instances that we have. And the last thing I want to show you, you see, so it finally worked, MVC 5, so it was taking longer, but you see, if I go here now, pods, deployments, yep, it just took a while, but we have now 5 of 5 when scaling out. And the last thing I want to show you is the metadata. So yeah, right here, Kubernetes, MVC. So this is the only thing that I need to deploy these containers into Kubernetes, a single file per deployment. In this case, is for the MVC application. I can open this with VS Code or whatever editor or even Notepad. And I just want to show you that this data is kind of similar to the data that you have, or metadata that you have in the Docker Compose files. But so you can see here, this is the name of the application, and this is the important thing, the image. So this image, because it's eShop/modernize MVC, by default, it's going to try to get this from Docker Hub. And then the rest of the things are the same things that we had in Docker Compose override. So we have the connection string, we have use mock data files, so it's going to use the connection string and the data, and then the ports that it's going to be using, redirecting the external port to the internal port of the container. But it's kind of the same metadata that you have in Docker Compose, just different format. And if you want to deploy this from the command line, you would do a command like this one. Yeah. So you just need to be you just need to be in the folder where you have that YAML file and run kubectl create and pointing to that YAML file, and then it will deploy that into Kubernetes. That is precisely what I'm doing from VSTS, also for Kubernetes. So again, we come back to VSTS. About the build pipeline, is exactly the same. We are not doing anything different here. It's pushing to the registry, so nothing different here. The difference is here in Kubernetes. So we grab now the YAML file for Kubernetes from GitHub, and then we have different tasks. That's the thing. We deploy the SQL container pointing to the YAML file for SQL, like the file I just showed you, or deploy the MVC application pointing to the YAML file for the MVC metadata container, and finally just refreshing, just so it makes sure that it's grabbing the last image, and that's all. I'm not going to do it, but you could just create a release and deploy to Kubernetes, okay? Which is already deployed in there. And okay, let's come back to the talk. So we are in the DevOps ready, so that's why I was saying that the important thing here was most of all Windows containers, which is going to make a lot easier for you to have a DevOps ready environment. And the only constant I see is that initially you have a learning curve about Docker containers, but it's just a little. I mean, you don't need to change your code, your bits of your existing applications. You can containerize with Windows containers, as I showed, and then have all the benefits of the Windows containers, okay? Here, you have a few resources on how to move data and configure the application. And now we're going to just introduce Cloud Optimized or Cloud Native, which is about microservices and so on. Ankit is going to do that. But this is just to kind of let you see further. It's not really the core of the talk.
Right, thanks, Cesar. There was a lot of demos in there, a lot of stuff in there. Thank you.
Thank you.
So the last section here we want to talk about is Cloud Optimized. And as Cesar said, that we're not going to get into this in a lot of detail, but we want to give you an idea about what it will take for you to be able to take your existing app, move it to the cloud, and, and optimize it for the cloud. So what does Cloud Optimized mean? Cesar kind of like got into this a little, but what it essentially means for existing apps is that you extend your apps with new services based upon cloud-native technologies like microservices, serverless computing, even PaaS services like Azure App Service. And what this allows you to really do is it allows you to fully exploit the advantages of the cloud. So one of the advantages that you'll see here listed is actually you get maximum or long-term agility. So this is an interesting point because we kind of like covered that at length in the cloud DevOps section as well, where with containers and you're deploying containers with orchestrators and CI/CD, you're getting agility there too. So what does the long-term agility or maximum cloud value mean here? Let me give you an example here. So here's an example of a traditional application that many of the folks have here and probably have built over a period of time. And what happens in these traditional apps is that the functionality is kind of like, wrapped within a few processes. And when you're trying to go and scale these processes, monolith applications up, what you're really doing is you're actually cloning this process, and you're deploying this process across multiple VMs or containers or servers today. And that's kind of like, the way of doing business. Now, with microservices, what's really happening is that at a high level, from an architecture perspective, what you do up front is you want to segregate functionality of your app. Like, so if you have like a banking app, billing, customers, and all that kind of stuff, you want to segregate those different functionalities into separate smaller services. And once you've done that, all of a sudden you start getting the benefit of being able to deploy each service independently. So you don't have to go deploy the entire monolithic app every single time. You can now deploy the smaller component of that app or the smaller service that you've created, a microservice that you created for that component, and deploy that separately. In addition to that, you can also scale these differently. So these are some of the kind of like advantages when you talk about what maximum agility brings to the table. So if you're working in a team, there's a lot of people involved, more remote teams involved. Having microservices is going to allow you to isolate some of these deployments. It's going to allow you to have that agility that you really need, for that cloud optimized kind of like environment. So that's kind of like one example there. And some of the call outs here are just kind of like repeating what I just said. So the other advantages that you'll get with this approach, in addition to long-term agility, is all the stuff that you get before. So now you get scale and high availability, similar to the story that we had for Windows containers. And now you're also using all the modern architecture stuff, which checks all the right boxes these days: microservices, containers. So those are kind of like some of the advantages that you'll see with this approach. We don't have a lot of time left to get into a lot more detail in this one, but I just want to cover this very briefly. How many people here have heard of Azure App Service or maybe use Azure App Service today? Oh wow, there's a few hands there. So the way we position, so we actually had to think about this one. I think me and Cesar and I think Andrew Hall at the back, we had to kind of like think about this for a while on how do we actually position Azure App Service. Is it cloud DevOps ready? Is it cloud infrastructure ready? The way we think about Azure App Service is really it's cloud optimized. It's pretty much the best solution out there that we can offer you. The only problem with Azure App Service is you need to ask yourself this question. Does your app actually have any custom dependencies? Does something need to be installed on those machines? Is there a need for you to be able to SSH to that box and be able to do something there? And if the answer to that question is no, then you can actually go ahead and use App Service. The only condition there again is that it just basically depends on pure system web or just .NET Framework pure. But other than that, you can actually, this is a great solution for you. Having said that, if your app does have dependencies and it's using, it has dependencies that need to be installed and so on, then a different choice is what we recommend, which is the Windows container stuff that we kind of like just demoed at length. So that's kind of the way we're thinking about Azure App Service. We welcome any questions at the end. But essentially, that's the story that we have for Cloud Optimize. And the only kind of disadvantage of this one is that there's a lot of work involved, perhaps up front. Re-architecture, refactoring, sometimes doing brain surgery to your existing app. That might not be easy. That might be hard. But other than that, you're getting the maximum cloud benefit and so on. So just to wrap it up, from a maturity model perspective, here's what all the stuff we talked about. We went over a lot of stuff. But just to recap this very briefly, again, the way we think about the maturity model is in two stages or two approaches: lift and shift approach, which we break down into cloud infrastructure ready, which is really about you, rehosting your apps and VMs. And then cloud DevOps ready, which is basically about you creating an automated CI/CD workflow after containerizing your apps with Docker server containers, and then pushing them to the cloud for scaling and high availability using orchestrators like Service Fabric or Kubernetes, and so on. And the last option on the right, we just talked about this one. This is Cloud Optimized, and this is really about using microservices and all the other kind of great stuff that's out there these days. So are you guys actually, at this point, I would say that, am I actually ready, or is there anything else that we need to consider? So we've kind of like shown you all the tricks, we've kind of like shown you all the stages, but you know what? There's a few other things that you might have to consider, and these actually apply to all these three different stages, whether you're going cloud DevOps ready, or infrastructure ready, or you're trying to build an app with microservices or serverless computing. And these things that you might want to consider are kind of like things like this. How I'm going to migrate my data? We at Microsoft give you a lot of options, sometimes too many, and you'll see in this page that you kind of have like three options here. So there is on the far right, there is the Azure SQL Database Management Instance. This is basically a PaaS offering from Azure, and this will give you all these things like built-in HA, scaling, upgrades. It will give you inbuilt security with VNet support for private IP address, and this is kind of like the best solution out there because it's going to eliminate both your hardware and administrative cost. The only problem is this is actually in preview. So another solution that might work for you is SQL Server and Azure VMs, and this is also a great solution. But with this one, the only problem is that you're still relying on manual patching, and you don't get high availability and scalability for free. You need to kind of like set this up yourself. Now, we did talk about the Azure Database Migration Tool, which is really a great service for you to try. which can actually help you move your existing data from SQL, MySQL, or Oracle into this solution. And for some of you folks out there, none of these two options might apply. Yes.
One thing I want to mention is the other possibility that you would have here is just the plain Azure database, Azure SQL database, okay? You don't see it there. That is the best case for simple databases. But since we were talking about migrating existing data, chances are that your actual database in a SQL server has many things that you cannot upload into a regular Azure SQL database because it's not exactly a SQL server. And that's why we are releasing the Azure SQL Database Managed Instance. And the difference with Managed Instance is that almost like 99% of what you have in a regular SQL server, you can run that in SQL Database Managed Instance, while at the same time it is PaaS. So it is managed, and you don't have to take care of everything at infrastructure level as a VM. Okay, so that's to clarify that.
Yeah, and I think Azure SQL is actually a great option for greenfield apps as well. So that's something to look into. But the last option here that you'll mention here is basically, in some cases, you might be working for a regulatory business, and you have requirements on keeping the customer data on-prem. And in these cases, Azure is actually still a great option because Azure does support hybrid scenarios. The only additional thing that you might have to do is set up VPN site-to-site or point-to-site, or you might have to invest in ExpressRoute, which might be for mission control workloads, you might have to invest into that. But other than that, these are kind of like the options that you have on the table. Depending upon the scenario, one might work better than the other. But this is kind of like stuff that you'll have to think about as a problem. What do you do with your data? Another problem you'll have to think about is what do you do about identity? A lot of existing ASP.NET apps use Windows Server Active Directory. So when you're moving to the cloud, this problem is actually easier, in my opinion. You can actually start using Azure Active Directory. Some additional recommendations that we'll also recommend while you're kind of like transitioning or modernizing your app are these on this list here. So some of you folks are still using an older version of .NET. Some of the folks are using 2.0. Some of the folks are using 3.5. And what you can also do as a part of the modernization story as you're kind of like moving to the cloud is also kind of like recompile your app to use a later version of .NET. This is going to give you more performance and improvements and more security improvements. Something else that we've seen folks run into is the ASP.NET caching issue. ASP.NET supports in-proc caching, which means that it actually caches your session data for folks coming in and trying to use your website and so on. So this works great if you're running on one web server, but if you're trying to scale this to the cloud with many VMs or many containers, you might have to invest. You will most likely have to invest in distributed caching there. And Azure Redis Cache has a session state provider that you can look into for a solution for this problem. A couple of other things there that come to mind as well is centralized logging. So imagine if you're running your code in like 10 containers in a VM, and all of them are writing to a single file, or all of them are writing to a file in each of their separate container silos. Imagine trying to do some troubleshooting or trying to look at those logs. That's going to be a nightmare. So investing in centralized logging with blob storage is probably a really good way to go to have all that logs flowing through nicely for you. File storage is another option that's available. And the last thing there is about security. And this really depends upon your requirements and needs for your business or for your customers. But Azure has a whole slew of tools here. You can use encryption, you can use multi-factor auth, you can use role-based access, you can use hardware security model, and there's a lot more options out there. But these are some of the things that you'll have to think about in addition to which maturity model works for you. Does lift and shift work better for you? Does cloud optimized work for you? But these are some things like data migration, identity, security, thinking about what .NET version I'm going to use. These are some of the things that go across these things in the maturity model that we talked about. So that's kind of like the stuff that we pretty much had for today. The only kind of like call to action that we have is that everything that we've talked here, there's a lot of stuff that we talked about. There's a lot of stuff that Cesar actually showed you folks today. You should take a look at the book. The book actually goes into this in a lot of detail. The book also has the links to GitHub and reference applications that you can take a look into and see if you want to get started from there.
I also want to show you this in GitHub. So all the demos that I did, it's not just that we are providing the demos. if you go to the repo eShop Modernizing and go to the wiki, so everything step by step, let's say I want to deploy to Kubernetes. So you have everything, all the details, the scenario, and how to do everything step by step in Azure, all the commands to create a cluster, to deploy manually, to deploy from VSTS, and so on. So, or the same thing for Service Fabric, or the VM, or everything. So it's not just we're providing the demo, but also the step-by-step to start from scratch, okay?
Right. And I think that's pretty much what we have for you folks. If you go back to the slide deck, Cesar.
Yeah.
And the last thing that we have is that we were trying to keep the .NET architecture page, which is the thing on the right, very current. We're creating new content. We're updating the apps. So if you want to bookmark this page, that will actually really help us. There's also a link to provide us feedback on this page. So if you're looking for any content that we haven't covered yet, or if there's any ideas or bugs or issues that you're hitting into, give us feedback. We'll get that addressed. But that's really what we had today, and we really appreciate you folks being here. So thank you, and have a great rest of the night. Cesar, do you want to say anything else?
No, just thanks a lot.
Is there any questions?